Hi, I'm Professor Bob Kalin of the University of Strathclyde. Welcome to COP26 and this session on groundwater. We provide here an example in Malawi where groundwater resources play an important role for the people of Malawi, for their ecosystems, and importantly for the water-food-energy nexus. Without groundwater management, the adaptation to climate change will be a huge challenge.
With climate change, we have had droughts, and then there's groundwater depletion in the ground surface, and we are kind of like now being forced to go into looking at deeper aquifers.
Malawi is a country in sub-Saharan Africa with a population of over 18 million people, 85% of which are dependent upon groundwater. It has two seasons, a rainy wet season from November until the end of March, and a dry season from April until the end of October. Lake Malawi is a substantial surface water supply, and even though the population depends upon groundwater, it wasn't until a recent national audit of all rural water points that more was known about groundwater as a resource.
Activity itself was done on the ground, reaching out to each and every water point, either improved or unimproved, but it was all mapped, and then sanitation facilities were also mapped together so that we can see the difference, the proximity between the two.
Substantial data was collected on over 100,000 water points to evaluate their functionality, their management, and the resource sustainability.
The issues of data goes a long way in making that we are planning well, because you can't plan if you don't know how much resources you have, how much facilities are there, in what state. So the data that is there is assisting so much in planning.
We were surprised to find how critical annual groundwater table variations were. Over 17,000 rural water supplies did not provide adequate water at the end of the dry season. And detailed data shows annual and ENSO variations in groundwater levels with a long-term trend in water table decline. And this is important because it's groundwater that provides the water flowing in the rivers during the dry season and when it's not raining. Study of the groundwater surface water link found that across Malawi, groundwater accounts for more than 50% of river flow, and for some catchments over 90% during the dry season. Given many of these rivers feed Lake Malawi or our transboundary, groundwater storage capacity is of national and international importance. The end results suggest groundwater is the resilient resource. It provides water to wetlands and rivers, which in turn provide water to Lake Malawi. Groundwater storage buffers the annual wet and dry seasonal changes, as well as climate variation and the effects of climate change. The management of groundwater resources in the face of deforestation, land use change, and increasing climate variability must be a priority, as it also supports energy security. Water from Lake Malawi flows out the Shiri and provides most of the hydroelectric power in Malawi.
It has also changed the amounts of water that we want, because with floods and then the droughts, we have to the people have to change a lot of things, maybe the type of food that they are now supposed to be having, or maybe the type of crops they are supposed to be growing.
And planning is underway for substantial investments in irrigation infrastructure and agriculture for food security. The success of these interventions will be dependent upon well-managed groundwater resources. This highlights a need for science-based policy revision to support Malawi's Vision 2063.
Revising of the national water policy. We have engaged the academia, we have engaged the NGOs, we have engaged the many other relevant stakeholders for their input. By the end of the day, we are trying to come up with facilities and structures which are resilient to these shocks. But at the same time, make sure that we are making available water resources for the country without depleting the environment for the sake of future generations.